Our next lesson is called Application of Systems of Inequalities. You're going to begin by completing the opening exercise. An economics class formed a company to sell school supplies. They would like to sell at least 20 notebooks and 50 packs of pens per week with a goal of earning at least $60 per week. Write a system of inequalities that can be used to represent the situation. So please pause the video and resume when you are ready to go over the answers. Okay, now that you've had a chance to check, we're going to write our system of inequalities. First, no variables were chosen for me, so I must pick them and define them. So I had let x equal the number of notebooks, and then y was equal to the number of pens. Now looking back to my problem, I see they would sell at least 20 notebooks. So my notebooks were x. X would have to be greater than or equal to 20 to show at least, which means 20 or more notebooks. Then I see 50 packs of pens per week. Remember, again, that's at least. So y has to be greater than or equal to 50. And lastly, we have a goal of earning at least $60 per week. So now we're talking about bringing in the value. It's $2.50 for each notebook plus $1.25 for each pack of pens to be a total of at least $60. So again, greater than or equal to 60. Then you're going to see name 5 possible situations for this system. What set of numbers does our solution belong to? Okay, so here are the answers I had. I put 20 and 50, x and y, that satisfy all 3 of those inequalities. 21 and 51, 22 and 52, 23 and 53, and lastly, I had 23 and 51. Please put underneath this, the key to picking these possible solutions, and it says what set of numbers does your solutions belong to, is that x and y must be whole numbers. Because remember, you're not going to buy half a notebook, a quarter of a pack of pens. It needs to be a whole number. So I hope from doing the opening exercise, you see that application of systems of inequalities is different than having a system of equations. For a system of equations, you have 2 equations that you're solving graphically or algebraically to find one solution where the x and y values are the same for both. This one is different because you have to fit certain criteria, and you'll see through our examples how that looks. So we'll look at example 1. Josephina works between 10 and 30 hours per week at a pizzeria. She earns $6.50 an hour, but can earn tips when she delivers pizza. Write a system of inequalities to represent the dollars she could earn for working between 10 and 30 hours. So we have 2 things going on here. We've got the number of hours she's working. So I said let H equal the number of hours. And then I said D, this is going to be for dollars because this is the money she earned. Now there's 2 things going on in this situation up top. First one is we're talking the hours have to be between 10 and 30. So that means 10 is my lowest number. H has to be greater than or equal to that, but it's still at the same time, so you're going back to that compound statement of and, has to be less than or equal to 30. This is our domain, what we're allowed to put into the inequality. As far as money goes, she earns $6.50 an hour. So that's where we're going to use in our second inequality for her total earned. Her total money earned has to be greater than or equal to $6.50 an hour. So then it says, if Josephina received $17.50 in tips and earned a total of $180 for the week, how many hours did she work? So now we're just going to take the actual inequality, D is greater than or equal to $6.50, and change it into an equation because now we're trying to find the exact answer. So we know we're going to do $6.50 times however many hours she works. Plus now we know she made $17.50 in tips. So that goes on as an addition to that. The total of $180 a week is going to go in for D. So this changes into 180 equals $650H plus $17.50. So now we want to get H alone. We'll subtract $17.50 first. And we end up with $162.50 equals $6.50 times her hours. Now if we divide by 6.50 on both sides, H is alone, and we get 25. So how many hours did she work? She worked 25 hours. Now moving on to example 2. Opal makes $15 an hour working for a photographer. She also coaches a competitive soccer team for $10 per hour. Opal needs to earn at least $90 per week, but she does not want to work more than 20 hours per week. So in part A, they would like us to define the variables X and Y and write a system of inequalities to represent this situation. So we'll let X equal her first job, which is the photographer. So we have number of hours for photographer. And then Y will equal her other job, number of hours coaching. Now we're going to go back up to the word problem and dissect this. First, we know photographer, $15 per hour here. Soccer team, $10 per hour. And she wants to make at least $90 per week. So that would be 15x plus 10y is greater than or equal to 90. So that's bringing in our value. We're putting how much she's making at each job times the hours she's working for that job. So the second one, we'll leave a little space here, put it down here, should be the total number of hours. It says she doesn't want to work any more than 20 hours. So that means she's got to be 20 hours or less. So for that, you want X plus Y is less than or equal to 20. So we'll do that one first since it's towards the bottom. I'm going to get this in mx plus b form by subtracting x. And I get y is less than or equal to negative x plus 20. So now I know my slope is negative 1 over 1, which means I'm going down and right. And my y-intercept is a 20. If you wanted to take your graphing calculator and type this in as if it were an equation just to get the table of values and use the table of values instead, you could. Then we have 15x plus 10y is greater than or equal to 90. We'll move our x's to the other side by subtracting 15x. And we get 10y is greater than or equal to negative 15x plus 90. But then we still have to divide by 10 in order to get y alone. So now we have y is greater than or equal to negative 3/2 x plus 9. So my slope is negative 3 over 2, which means I'm going down 3 to the right 2, and I have a y-intercept of 9. And again, you could just type this in your graphing calculator and use a table as your work instead. So now we're going to label our graph. We said that x was the number of hours for the photographer, so we'll put that down here. Which means that the number of hours for coaching goes on the y-axis. So number of hours coaching is here. Now, I'm going to go back up to my x plus y is less than or equal to 20. I'm going to choose to go by ones because I can fit everything in here. So we'll mark every 10. So this is 10, and this is 20. 10 and 20, and this is 0. So now we know we're starting at a y-intercept of 20, and we are going down 1 to the right 1. Now, when we think about connecting these, we have to think about the type of line. So since it's less than or equal to, we want a solid line. I'm not putting any arrows on the ends of those because that would imply going into negative territory, which we should not be doing if this is about hours working a job. The second thing, remember from last chapter or for previous lessons, we have to do is think about the shading. So think about checking the point 0, 0 in x plus y is less than or equal to 20. If I do that over here on the side, we'd have 0 plus 0 is less than or equal to 20. 0 is less than or equal to 20. That is a true statement. So I want to shade down towards 0, 0 for this inequality. And then I want to put my original inequality as my label, which is x plus y is less than or equal to 20. Okay, I'm going to switch to a different color just so you can read it a bit easier when watching the lesson. My other one is going to start at 9. And I'm going down 3 to the right 2. When thinking about dotted or solid, it's greater than or equal to. So I want to make it a solid line showing that those are all answers. And then we want to check 0, 0. So 15 times 0 would be 0. Plus 10 times 0. We want to see if it's greater than or equal to 90. You'd have 0 plus 0 is greater than or equal to 90. So 0 is greater than or equal to 90, which is not true. So we don't want to shade towards 0, 0 for this one. We want to shade the opposite way. And I like to make them kind of go in a different direction so I can easily see the cross-hatching that happens, especially since you would not be using different colors. And now I'm going to mark this with a big S showing that whole area is my solution set. And of course, label this inequality with its original. 15x plus 10y is greater than or equal to 90. Okay, so now in part C, we want to give two possible solutions to describe the situation. So obviously, these are just a couple of examples of what we could do. But if you want them to fit the situation, then you need to make sure you're picking coordinates that satisfy both. So for example, the first point I picked was 7, 8. If I go back up here and I find 7, 8, it's right here, and I see that it falls in the double shaded region, so it satisfies the entire situation. The second point I came up with was 15, 2 for the same reason. Now, why don't you try to find another solution or two just to make sure you're comfortable with it? And we've talked about this before. If it's a solid line, you can technically pick a point on that solid line for counting. In part D, it says, can Opal work 2 hours for the photographer and 2 hours coaching and earn at least $90? Using your graph to justify your answer. Now remember, if it says that, you have to describe using the graph. You're not allowed to use any algebraic reasoning or inequalities to answer that. So 2 hours photographer and 2 hours coaching would be a coordinate of 2, 2. That's right here. It's only in the blue shaded region, not the teal shaded region. It's not in the double area shaded region. So down here I will say no. 2, 2 is not in the solution set of both inequalities. And that concludes your lesson on applications of systems of inequalities.